Grandpa stands up from the couch. The couch says creak. Grandpa says creak. And the dog looks at both of them like, which one of you needs oil? On the table, there is a banana that was yellow yesterday. Today, it looks like it joined a tiny brown-spotted detective agency. Our curious kid points at the banana. Then he points at Grandpa. Wait, bananas get old. People get old. Even my sneakers get old. But why? That sounds like an easy question. Things get used. Things wear out. Mystery solved. Except, your body is not just an old pair of sneakers. Your body is alive. It fixes cuts. It replaces cells. It cleans up messes. It even builds new parts while you sleep. So here is the real mystery. If your body is always repairing itself, why do we still get old? Imagine your body as a statue. Rain hits it, wind scratches it, time slowly chips it away. That would make aging simple. But your body is not a statue. It is more like a busy city that never closes. Skin cells are replaced, blood cells are made, bones remodel themselves, tiny repair teams patrol for damage. Inside you, it is rush hour all the time. Trucks deliver nutrients. Power plants make energy. Garbage crews pick up cellular trash. Librarians guard DNA recipe books. That is why the question is weird. If Body City has repair crews, cleanup teams, power plants, and instruction manuals, why doesn't it stay brand new forever? The answer is not, because one magic aging button gets pressed. The answer is more like this. Over many years, tiny problems happen faster than the repair crews can perfectly fix them. Not all at once, not in one place. Little by little, the city gets a maintenance backlog. Think about a school backpack. On Monday, one paper gets crumpled. On Tuesday, a pencil leaks. On Wednesday, a granola bar becomes archaeology. None of those things destroys the backpack. But if nobody cleans it for years, you may discover a new life form named Crumbzilla. Body City has a similar problem. Every day, cells do millions of jobs. They copy instructions, burn fuel, fold proteins, send messages, divide, repair, defend. Most of the time, this works amazingly well. But amazingly well is not the same as perfect forever. A few DNA letters get damaged. Some proteins fold into the wrong shape. Some power plants get smoky. Some cells stop working, but refuse to leave the office. Aging happens because many small changes build up across the whole body. It is not one villain. It is a lot of tiny sticky notes that say, fix this later. First stop, the DNA library. DNA is like the body's recipe book. It tells cells how to build and run you. The librarians are very serious. They wear tiny glasses. They whisper, no juice boxes near the chromosomes. But DNA lives in the real world. Sunlight can damage it. Chemicals can damage it. Even normal energy making can create little sparks that damage it. Your cells have repair tools, and they fix damage all the time. But over decades, some smudges and typos can remain. Cells also have protective tips on chromosomes called telomeres. A telomere is like the plastic tip on a shoelace. It helps keep the chromosome from fraying. When some cells divide again and again, those tips can get shorter. When the tips get too short, the cell may stop dividing. That can be useful for safety. But it also means some repair jobs become harder later. Next stop, the cell factory. Cells make proteins. Proteins are tiny machines, tools, signals, and building blocks. But they only work if they fold into the right shape. Imagine origami cranes. Fold them correctly, and they look beautiful. Fold them while riding a roller coaster, and now you have a paper meatball. Cells have quality control workers who help proteins fold correctly and recycle broken ones. But with age, more folded wrong proteins can pile up. Now visit the mitopower plants. Mitochondria make much of the cell's usable energy. They're like tiny batteries with hard hats. When they work well, the city has bright lights and smooth traffic. When they become less efficient, cells may have less energy for repair. And tired power plants can create more messy sparks. So the city needs energy to repair damage. But making energy can also create damage. That is deeply unfair. The mitochondria file a complaint. Now for the weirdest part. Some damaged cells do something very smart. They stop dividing. This can help protect the body because a badly damaged cell should not keep copying itself like a broken photocopier. Scientists call these senescent cells. For our cartoon, they are grumpy retired workers. They sit in tiny lawn chairs yelling, "Back in my day, proteins folded uphill both ways." A few grumpy retired cells can be helpful. The problem is when too many hang around. They can send out cranky chemical messages. Those messages can annoy nearby cells and bring in immune police. Over time, the whole neighborhood can become a little inflamed. Inflammation is not always bad. It helps fight infections and heal injuries. But low-level, long-lasting inflammation is like an alarm that will not stop beeping. Meanwhile, the stem cell construction crews can become less ready to rebuild tissues. So the city still repairs, just not always as fast, cleanly, or quietly as before. Here is the surprise. Aging is not simply your body failing. Many aging-related changes started as protection. Stopping damaged cells from dividing can help prevent bigger problems. Inflammation can help you survive germs and injuries. Repair systems spend energy carefully because your body has to balance many jobs at once. That means aging is full of trade-offs. Also, not every part of the body ages the same way. Your skin, muscles, brain, blood vessels, immune system, and gut can all change at different speeds. Even two people with the same birthday can have bodies that seem to age differently. Genes matter. Life matters. Luck matters too. So when someone says aging is just this one thing, imagine Body City workers holding up a giant sign. Excuse us, it is complicated. So can we stop aging? No magic button. No secret smoothie that makes you 12 forever. If a bottle says that, the bottle may be wearing a tiny fake mustache. But we can help Body City do its repair work. Sleep gives cleanup crews time to work. Movement tells muscles, bones, blood vessels, and energy systems stay ready. Food gives the city building materials. Sunscreen helps protect skin DNA from too much ultraviolet light. Not smoking keeps extra damage out of the city. Friendship, play, learning, and less constant stress may also help the body stay more balanced. These habits do not make anyone immortal. They do not guarantee perfect health, but they support the systems your body already uses. Repair, cleanup, energy, defense, and communication. Basically, you're not trying to defeat time with a laser sword. You're giving the repair crews better snacks, better tools, and fewer exploding glitter cannons. Scientists are still trying to understand aging. They study DNA damage, telomeres, proteins, mitochondria, senescent cells, stem cells, inflammation, the immune system, and even the tiny microbes living in us. They have found many clues, but there is still no single master answer. And maybe that is what makes aging so interesting. Getting older is not just a sad story about things wearing out. It is also proof that your body has been doing an unbelievable job. Every heartbeat, every scraped knee repaired, every cold fought off, every night of quiet cleanup while you were dreaming about pancakes riding dinosaurs. Body City has been working for you since before you were born. So yes, we get older because tiny problems slowly build up. But we are here because tiny repairs happen constantly. Aging is the story of both. Not perfect forever, still astonishing every day.